we'll get started with our session. So tonight we're going to be reviewing Niagara spars and standing rigging. So kind of where we left off last week. We're going to be reviewing the standing rigging, build a brig. And then our main topic tonight is going to be introducing some concepts in rigging and marlin spike seamanship. Hopefully there will be a lot of good information and value for you there. And then at the end, we're going to be talking about sending up a mast and that process. We did have some questions in the Facebook group about that last week, and I tried to bring some pictures and make a little bit of a drawing to make it a little bit easier to understand, hopefully, for everyone. So build a brig. This is where we're going to begin this week. So I'm going to go ahead and get my drawing tools up, and we will go through the process of building our brig. So first, we're going to start with the spars. So this is this blank sheet here is available on the course resource page. I do also believe it was shared on the email last week. So you have this blank sheet that you can print out if you like, and you can use it to go through this whole process yourself, which I would recommend. It's the best way to kind of go through the learning process, learning the terms, learning the different aspects of the rig, and then even at the end, you could label it all to help you to study. So let's go ahead and get right into it. So I'm going to go ahead and throw up our lower mast. So that's the main mast. We have our foremast, and then we're going to have our bowsprit. Then moving out from there, we'll have our jib boom, our fore topmast, and our main topmast. Then as we move up and out, we're going to have our flying jib boom, our fore topgallant mast, our main topgallant mast, and then if you remember from last week, the topgallant mast and the royal mast are the same spar, but at the main topgallant hounds, the royal mast has a smaller diameter, but we still treat it as a separate mast for a lot of the rigging. Some other spars we want to make sure we include have the martingale, and then we also have the bowsprit. We want to make sure we get on there. Sorry, not the bowsprit, the sprit yard. That'll be crossing underneath like that. I'm going to throw our two other spars there, our spanker boom, spanker gaff, and our snow mast on here. So just behind the main mast, there is a smaller mast that goes from the fighting top down, and that is the snow mast. And that is there for the spanker boom and the spanker gaff to get rigged off of. Next, we're going to get into the standing rigging, so we can keep our masts and our bowsprit and our head rig there in place. So first, we're going to be working with our bobstays that pull down on the bowsprit, and then what's going to be pulling against those bobstays, we're going to have forestays. that does remind me, I'm going to throw in, and this is, you can do it in any order you want, but I wanted to throw in some of the fighting top. So our fore fighting top, main fighting top. We'll throw on here our lower mast cap for the fore, lower mast cap for the main, some cross trees for the topmast, and also throw on a cap on the topmast as well, just for our visualization of the standing rigging as we're doing it. So far we have our bob stay and our fore stays. For the main, we're going to have our mainstays. And I will have a picture at the next slide here once we get through build a brig that we'll actually look at a picture of the ship and talk about that too. So those are our lower stays. Then as we work up the topmast, change colors here, we'll have our topmast stays. Then we'll work up to our topgallants. With our topgallant stays. And then finally, the last level up, we have our royal stays. Now, do remember that most of these stays are going to have two, so they're going to be doubled up. So our fore stays, main stays, and our topmast stays will all at least have two stays associated with it. And remember, stays are keeping the mast from falling aft or backwards. Next, we're going to talk about back stays. So for the lower masts, we don't have backstays. The lower mast shrouds act as backstays. But the next level up, the topmast, will have backstays. So we're going to go with the topmast. Topmasts are actually going to have two sets on either side. But we're just going to draw it in as a single one. So you'd have a starboard fore topmast backstay or a port fore topmast backstay. And then working our way up, we have our topgallant backstays. So fore topgallant backstay and our main topgallant backstays. Again, they're going to have a starboard or port side to them. Now, the royal masts do have backstays, but these are going to be running. And what that means is that they're going to have a block and tackle or tackle set up that we can adjust the tension of those running backstays. So I'll go ahead and throw in kind of a quick representation of a couple blocks and tackles. So, but those are the royal backstays. Again, a starboard and port for each mast. Now we're going to get into the shrouds. All right, so for our lower mast here, still have a circle there. Now we should be all set. So our lower mast here, lots of colors. Again, we're going to have a starboard and a port for each mast. So this, what I'm drawing here is going to be our starboard main shrouds. And as I'm drawing this, just remember the ship does have, the masts do have a little bit of rake to them. So they're not straight up and down. They do have a little They are tending to lean aft. So now we're going to go to the topmast shrouds. So the topmast shrouds are coming down to the fighting top. And then they connect to some irons that then connect to the futtock shrouds, which then go to the lower shrouds. So here are my starboard four topmast shrouds, and then my starboard 4 futtock shrouds. And again, we'll have this on the port side as well. So those are our topmast shrouds, and then we'll work our next level up here. We have our topgallant shrouds. Oh, I want to go with maybe a yellow here. We have our topgallant shrouds. They actually go down to the fighting top is where they're tuned from. So they go through the ends of the cross trees. There's some grooves there, the end of the cross trees. They cross to go to the fighting top, and that's where they are tensioned. So those are the shrouds. The royal masts do not have shrouds because if you remember, the royal yards are not rigged standing, so they're on deck. And then when we want to set them, we send them aloft, so they're considered flying. So here we are. We have our stays. So a few of the words here I haven't gone over because we're just talking about most of the parts. So the one here is the flying jib stay. So the flying jib stay would go from the topgallant to the end of the flying jib boom. And that's one of those where the topgallant has 2 stays. Those 2 stays, one's going to the end of the flying jib boom, the other is going to the end of the jib. That allows you to actually not even have the flying jib boom rigged, but still be able to have tension and support for the main or the fore topgallant mast in this situation. Then we could throw some yards on here. What color should I make them? Let's go with this. So this is going to get a little cluttered here, but we're going to have our, well, I'm making another size up. We'll go with black here. So we have our 4 yard, our 4 topsail yard, our 4 topgallant yard, and then our 4 royal yard. And this is if the royals were set. Then we're going to have our main yard, our main topmast yard or topsail yard, our main topgallant yard, and then again our main royal yard. From there, we're going to bend on some sail. This is where the drawing comes into place. I'm going to go with a bright color. Why not? All right, so for our fore and aft sails, make sure I have the right size. That's good. We'll see how it goes. Well, we have our flying jib, and we'll be talking more about sails next week. The flying jib has a running tack, means we can adjust the height of the flying jib. Hope you're appreciating the artistry going into this right now. Then next up, we have the jib. And that's going to have a fixed tack that's secure to the end of the jib boom. So it won't be able to go any further than just setting the whole sail. You can't adjust the height of it. And then we have the fore topmast staysail. Then in between, oh, Wyatt, good catch. I saw that. That's correct. That is the fore royal stay, and it should be on the flying jib stay, which you're right, it would be this orange one here. Good catch there. The next sail that we have in between the masts, we have the main staysail. That's on the main stay. Then we have the main topmast stay sail, which is bent onto the main topmast main topmast stay. And then above that, we have the main to gallant stay sail, which is bent onto the main to gallant stay. And then finally, for our fore and aft, we have our spanker, which is bent on to the gaff, and then it's loose-footed on the boom, and then laced and connected to the snowmast. So that's our fore and aft sails. Now we'll throw on our square rig sails. So starting here at the fore yard, we have the foresail, or the fore course. The course, the lower square sails are different than the other ones because they don't go to a yard below them. They go directly to the deck, which they have some rigging that the crew will adjust directly from deck instead of having it come down from aloft. Then above the fore royal, we have the fore course or the foresail. We have the fore topsail. Next above that, we have the fore to gallant. And then finally, we have the fore royal. And again, the royals are set flying. Then on the main mast, the main stack, we have the main course. Above that, we have the main topsail. Next above that, we have the main to gallant. And then the main royal. And there we are. There's our 15 sails, and we have a masterpiece in front of us. So just like I did it with everyone here, go through the process, draw in the lines, try to label as you go. You know, you can make lots of different copies, use colors if you want, but I think this is a really helpful way of trying to learn the terminology and also kind of the different concepts of what the rigging does. I'm going to go ahead and clear that, and we will carry on. So here we have a photo of Niagara under sail. And I want to point out some of the rigging that we were just talking about as we drew our build a brig. So we have starting with the masts, I would say. So we have the lower mast here. So this is the foremast. Then we're going to have the topmast to gallant mast, and then the royal mast. And then the same thing on the main topmast, main to gallant, main royal. Then up forward here, we have our head rig, which consists of the bowsprit, the jib boom, and then our flying jib boom. And we have our sails, our flying jib, our jib, our fore topmast staysail, our main staysail, our main topmast staysail, the main to gallant staysail, and then the spanker. And then we have our square sails. Starting with the fore, we have the fore course or the foresail. You can see how the corners of that sail go towards deck. There's some rigging, running rigging associated with it that are adjusted there. Then we have the fore topsail, which you'll see the lower corners go to the yard below it, which makes it a little different. Then we have our fore t'gallant, and then above that we have the fore royal. And again, this yard and the sail are normally stowed down here on deck and then set up behind the mast and crossed. And then finally on the main mast, we have the mainsail or main course, the main topsail, the main t'gallant, and then the main royal. Looking at the rigging, you see it, look at the bow here, we do have the martingale or dolphin striker there. It's difficult to see the sprit yard, but it's right here. It's a little bit in the shadow there, and we're kind of side on to it, but there is the sprit yard. In terms of rigging, we're talking about bobstays, where everything begins. That's where the bobstays are, and that's where they pull down on the bowsprit. Then we have the inner and outer forestays. Now we're looking at being able to show you that we have two stays there. Then we have an inner or an outer fore topmast stay, and then we have the fore topmast staysail. So we have an inner and an outer fore topmast stay, which on the inner fore topmast stay is where the fore topmast staysail is bent onto. Then as we go out, we have the jib stay. And if you're wondering, okay, what stay is this? You always want to look up what mast does it support? What hounds of the mast, or what mast does it go to? So in this case, these two go to the fore topmast, but these are referred to as the fore topmast stays. Well, this is the jib stay because this is the stay that the jib gets bent onto. Then right here, to the end of the jib boom, look up, oh, it's to the gallant, so that's going to be the fore t'gallant stay. And then as we go further out, I'm going to follow one. Oh, that's the one that the flying jib's on. Oh, so that goes up to the gallant, so I know that one is the flying jib stay. And then the last one up forward goes up to the royal, so that's going to be our royal stay. In between the mainmasts, the same idea. We have the two mainstays, so the inner mainstay, which the main staysail is bent onto and is set on. And then we have the outer mainstay. One thing you can notice in this, and we'll be talking more about this next week when we get deep dive into sails and how they're bent on, but you can kind of make out here on the main staysail a little more clearly the hanks that are bent around the stay, and then the sail is bent to, which is tied on with some marlin that we'll talk about. Next up above, we have the topmast stays. So the main topmast stays, then we have a main t'gallant stay, and then a main royal stay. And it's very difficult to make out any of the back stays or shrouds in this photo, but here we can see we have the four shrouds right here, and then right here we can make out the topmast, or the four topmast backstays. We have a fore t'gallant backstay and a fore royal backstay. And then the same thing on the main back here as well. Back in the spanker here, we have our spanker boom, our spanker gaff, which the spanker is bent onto. And then it's difficult to see, but our snow mast is back here behind the main mast. All right, we're going to carry on and get into the main chunk of our evening here. So we're going to be talking about marlinspike seamanship. So marlinspike seamanship is kind of the art of rigging, using knots, seizings, splices, lashings, whippings to rig and maintain a ship's rigging. So to create the rigging as well as to rig a ship, and then to tune it, seize it and to make sure it's properly maintained. So that all takes a lot of rope. So rope is the name of the game in terms of rigging on a traditionally rigged ship. Here are some of the tools of the trade that are used in regards to rigging and marlinspike seamanship. So every sailor on a traditional ship is going to have what they call their own rig. So it's going to involve the knife. So this is going to be usually going to be a fixed straight blade. And then they're going to have what's called a marlinspike. And on the top here, we can see this is an example of a marlinspike. Generally, most personal marlinspikes will be about the 8-inch to 10-inch range. But you can get marlinspikes of any size, whether it's really small for fine work or really big for working with a large splices or anything you're working with. So you can get really large marlinspikes as well. Some other tools right here on the left, we have some wood fids. Fids are used in splicing and knot tying and fancy work and many different other ways. You can use it in sail making a little bit, but usually it's working with rope and doing splices and the different types of rope craft and rope creation or building of different things. Right here is what's called a Swedish fid. What makes the Swedish fid is has that concave groove in it. Usually they are made of metal there, and that actually just makes it a little easier in particular for splicing when you're trying to get. And we'll talk briefly about different types of splices as we go through this session. Down here we have some sail making tools. One in particular I want to point out here. This is a sailor's palm here. Use that for when you need to push needle through canvas or leather, or even into a rope if you're doing what's called a whipping, which we'll talk about briefly. The back side of the needle goes into the metal grooves here that allows you to kind of push the needle through the heavy material that you're working with. Then over here on the right-hand corner, have some heaving mallets. Use these for just getting a lot of tension on usually a small line or small stuff that you're using to seize around another larger one. And the seizings are really what clamps everything together, which we'll also talk about. But these are all heaving mallets of different sizes, depending on what size of the cordage or small stuff or line that you're using. We have some of the tools of the trade in terms of the things that we use on the rigging. So pine tar is something that's heavily used. Some of the best stuff is the Swedish pine tar, Stockholm pine tar, it's often called. And that is usually put onto rigging for preservation, helps to keep the weather out and keep the sun off, and so it helps care for the rigging in that way. So it's good to make sure that your rig gets properly tarred in the appropriate places periodically for regular maintenance. Linseed oil and turpentine are mixtures or liquids that are added to, whether it's a pine tar mix, to paint, used on their own to coat or soak blocks, hanks, belaying pins, different types of parts of the ship's rig or tools used, and that can help preserve those, keep them from cracking, as well as them from wearing further as they're being used. Types of rope and rope construction. So we have a lot of different types of modern materials that are available to us, but we're going to be using on Niagara and many traditional ships, we use a natural fiber line called manila. Traditionally, it would have been hemp because hemp would have been widely available during that time period and widely used, but nowadays hemp is less available. And so manila, which is a type of plant from Southeast Asia, is used more often, and it has similar characteristics as hemp and looks similar as well. So that's a natural fiber line. We do have some synthetics, and actually most of the standing rigging is made of Kevlar, which is a synthetic type of material that we use for the ship's rig. Kevlar is nice because it actually has less weight and is actually stronger than, say, wire rope. Traditionally, they would have had hemp standing rigging, but that would be less favorable for us. One, hemp is going to deteriorate much, much faster, and it's also going to be less safe because you could have potential issues, whereas the synthetics hold up a lot, much longer. So those are good, and it's and safer, and again, much stronger, which is something that we care about in terms of safety, having precious cargo people on board. So rope construction, the type of rope that we have on board is going to be 3-strand. So it has the 3 different parts of the rope itself. So 1, 2, 3 strands. Those strands are going to be made of fibers or yarns, and yarns are going to be made of even smaller fibers here. And then on the right, you can see the 3 different strands made up of the yarns and then those fibers. So the fibers are going to have a right-hand laid twist. Then those yarns are going to be twisted to the left. And then finally, the strands will be twisted to the right. And so the type of line or rope that we use is right-hand laid. And that means the direction of the lay of the rope is going to be to the right. So no matter whether you're looking from it from one way or the other, it's going to be to the right. So this is important for us to know because it's going to dictate how we're going to use this line when we're coiling it. So it's important that when we're coiling a line on deck, making it ready to be used, or for stowing, that line is coiled clockwise or to the right, because otherwise there will be kinks and tension put into the line that you don't want. You can have left-hand laid line. That's available as well. It's not as normal on most ships today, but you can still find it on some of the lines, or some of the ships, or some lines. But on Niagara, we generally don't have left-hand laid line. Spun yarn, small stuff, otherwise known as marlin. So marlin, I'll point it out here. We have our marlin here, also down here in the right-hand corner. This would be marlin. Marlin is going to be either natural fiber or synthetic, and that's going to be used for either seizings, which we'll talk about, or also doing service, which we'll talk about. Then we also have a synthetic called seine twine, which is going to be a little bit stronger, a little bit more uniform, but it is synthetic. And this is used for some seizings, as well as it can be used for service, depending on what the vessel is going for. Next, we're going to talk about worm, parcel, and serve. So when you have a piece of standing rigging, whether that's going to be hemp, wire, or even Kevlar, you can do a process called worm, parceling, and service. So this is a process of, first, because of the 3-stranded or multi-stranded setup of the rope itself, or the line or standing rig that you're building, you're going to first worm. So worm is actually putting a smaller piece of rope or line and weaving it around into the grooves between the two, the parts of the strands there. So in the gaps in between them. And the goal there is to smooth out the rope so that you don't have bumps, you don't have troughs and peaks, so that you get a more uniform layer on the rope itself, or the rigging. The next is going to be the parceling. So the parceling is going to be just canvas, usually, old canvas, old sailcloth that has been cut up, and it's going to be go around the rigging, and you'll notice that the worming and the parceling are both following the lay of the piece of rigging that's being served. So in between this, I will mention that in between the worming and the parceling, you're also going to be putting a lot of pine tar in between these layers, again, for weatherizing that rigging that you're using and to also bind all the parts of the service. Finally, down here, C is the process of actually closely winding the small stuff or marlin around the rigging using a serving mallet. So over here on the picture here down in the lower part, we have a example of one style of serving mallet. You can have our older versions, let's say in the upper left-hand corner there, you can see one. This looks like they're training two young sailors here, but one has the serving mallet in one hand, and then the other has a ball of spun yarn or small stuff in the other hand, or in their hand, and they're actually just going to be following along, bringing that coil or that ball of marlin around with the rigging mallet so it doesn't just start wrapping up on the other end. With a lot of the modern ones we have now, we'll have different versions of this service mallet that has a spool at the end, so you don't have to have that extra person helping you out. In the middle picture here and at the top one, you can have different examples of the worming, the parceling, and the service. Then you have your small stuff or spun yarn or marlin. Traditionally, the marlin or the small stuff that was used would have been from the old rigging. So the old hemp rigging would then be unlaid, so all the strands undone, and then you would actually even make it even smaller from that, break apart some of the strands and the yarns, and use that as your service for wrapping around the new rigging. So you would actually use the old material to make new rigging. And right here on the upper right hand, you can see a serving mallet in work with a close-up of the marlin. You can see the tar that's being squeezed out of the different layers as they're put on. And so it's a messy job, but it's a lot of fun and it smells great. And I think this is one of the things that our volunteers miss the most about maintenance in the winter right now, is they're not able to go down and help out and smell all the pine tar. Some of the splices that we have the eye splice here. So this is going to put a permanent eye at the end of a line. So instead of tying a knot like a bowline, you would use an eye splice to do that. So there's lots of demonstration videos on YouTube. All you need to have is a 3-strand piece of rope. It doesn't matter if it's natural fiber or synthetic. If it's 3-stranded, you can go through this process and learn how to do an eye splice. Then you have the short splice. The short splice is going to be the stronger of the short and the long splices, but it's also going to be a little bulky. So you can see in the upper right-hand corner there we have our eye splice, but it's going to be a thicker diameter than the rest of the rope. And that can be an issue because if you're trying to have that rope pass through a block, it might not be able to, or it will likely get stuck. So you would do a short splice if you're cutting out an issue in the middle of a line. Maybe you had some chafe or some of the line coming apart, but it's not a line that needs to go through a block or anything. So that's something that you could do a short splice. It's going to be the stronger of the two. Next, you have a long splice. So a long splice, similar to a short splice, you're kind of unlaying two ends and connecting them and tying them together in a specific way. But this is done in a manner that it actually doesn't disrupt the diameter of the rope. It's not going to be as strong as a short splice, but depending on what your calculations are for your safe load for that line, you can use this to put a repair in a line if it's not going to severely diminish the strength of that rope or that line being used. Another type of marlin spike seamanship skill is going to be a rope grommet. So this is going to be the act of laying out a whole strand of a piece of rope and then laying it on itself in a circle until you get what appears to be a continuous piece of line like the rope grommet here. So step one, you have, this is a single strand of rope. So you have the 3 strands and you've laid out one of them or unlaid them all and got one of them. And then you start laying on itself, normally a 3-stranded piece of line. In particular, natural fiber line is going to be, is going to have a kind of memory to it. So it will tend to want to follow. Now, synthetic rope isn't going to generally hold that memory as well sometimes in a lot of the, especially the softer fiber synthetics, 3-stranded line, but the natural fibers tend to do that. Rope grommets are useful. They're used in sails, for clues and for eyes. They're used for many different things, but they're a useful marlin spike seamanship skill to learn. Then we have whippings. So whenever you cut a line and you want to have that rope be in service, you need to have a whipping at the end. The purpose of that is once you cut a line, as you can imagine, that line would start fraying everywhere if you don't have something clasping it together to keep it from fraying. So the whipping is the traditional process of doing that, because with natural fiber line, you can't melt the end, which you can do with synthetics, to keep it from fraying. So here we have the natural fiber line with a whipping on it, and it's wrapped around tightly. There's different versions of a whipping that you can do. In the middle picture here, you can see there's what's called a common whipping. So this whipping is done without a needle or thread, or it's not obviously it needs a thread, but it's done without a needle or a palm, and it's fairly easy to wind around the end of the rope and tie in place. This is not going to be as secure, so you can do other ones, say on the far right here. It's going to be a similar example of what's more likely going to be like a sailmaker's whipping, they call it, because using a needle and a palm, you kind of weave the needle and the line or the thread through a couple of the strands to help lock it in place, so that you can have a nice tight whipping that's less likely to come undone, so that your rope doesn't come frayed while it's in use. And very often we'll actually put 2 whippings on a piece of line that's being used part of the running rig on the ship. Seizings. Now, seizings are a huge part of what we do every uprig and downrig, and then some seasons do it a lot in season when we have to go have masts go up and down. But seizings are critical. They're the friction or the small stuff that really binds everything else together. So when you go from your large standing rigging to your lanyards, then you have your seizings that lock everything in place. So a couple of the things I'll point out here. We have different types of seizings. Round seizing here, a racking seizing. So a round seizing is going to kind of pull these 2 parts together around something. You can see a round seizing on the picture here to the left. Racking seizings are going to keep the 2 different parts that are parallel from moving. A throat seizing is going to allow you to really clinch a loop around say a heart or a dead eye, which is used. So normally we would have a Niagara have a throat seizing around this rigging here, and those are the main ones that I would talk about. Oh, I'm going to clear that. So round seizing again. And here we have an example of our Niagara's bosun. Here she is putting a round seizing onto what I believe this is the mainstay. And I think there's another photo of her doing that. So we have the mainstay. She's putting a round seizing on right there. And again, that's to clench the two different parts of that rigging together. And so she's using, you can see it briefly, she has a heaving mallet in her hand. And we'll see another picture. There's a rig vise here clamping the two parts together to allow her to do that round seizing there. Racking seizings, again, these are to keep the two different parts from moving opposite each other. So what I mean by that is on this picture here, one part of this lanyard wants to go that way and the other one wants to go this way. So the way to clamp them together, to keep them both from moving, is to tie one of these seizings. And you can see how many different seizings and racking seizings we have. And it's called a racking seizing because it kind of interweaves in between the two strands to have the most friction possible between the two and really clinch them together. And then you'll have what's called some covering turns on the around them, and then finally frapping turns in between to really tighten everything together. But we have hundreds and hundreds of seizings that have to go on to the ship every season to keep the ship rigged nice and tight after it's been tuned and everything in place. And I still love, and I think it's awesome how, and really cool how we have this huge ship, but everything really boils down to all these little small, pieces of rope, tied tightly around larger pieces of rope, that are then connected to larger pieces of rope, tied it around, and it kind of goes on. And it's all built on friction, which I think is pretty amazing. Throat seizings. Again, this is the clasp, the rigging around, say, a dead eye, which is demonstrated here, or a heart, or other type of material used for roving in a lanyard for tensioning or tuning the rig. So these are dead eyes. And so we have our lanyards here. And so the throat seizing is done right there where the two parts that come together. And then above the throat seizings, you have the round seizings. Obviously, there's a lot more to this, but we're kind of just briefly going over it so you have an introduction to different aspects of seizings. So blocks, these are going to be what, obviously a pretty fundamental part of rigging, running rigging, and being able to maneuver sails because they direct the angle that a rope is going, but also allow you to have what's called mechanical advantage. So you can have different block setups, different tackles with different numbers of sheaves, which allow you to then have increased mechanical advantage so that one person or many people can lift something that's much heavier than them. So generally how you want to kind of look at a block and tackle, if you want to know how much purchase is what we call it, that it would have, that you look at the moving block. So here, let's look at the kind of the gun tackle here. We have two blocks, but this one is fixed. So the lower block we're going to look at, if you count how many leads are going away from that block, that will tell you the ratio of the purchase that you're going to have. So for this gun tackle, it's going to be a 2-to-1 purchase, which means with 100 pounds of force, you could lift something that's 200 pounds. So 2-to-1. As we go to the one on the right here, the luff tackle here, you can see 1, 2, 3 different parts of this tackle here. So this is going to be a 3-to-1 ratio. And then for this one, the two-fold purchase here, we're going to have 1, 2, 3, 4 coming from this block here, the one that moves. So therefore, it's going to be a 4-to-1 ratio. Now that it's not going to be a perfect 4-to-1 or 3-to-1 in the purchase. There is going to be some loss to friction in the actual block system itself with the rope, but it's pretty close. It's about 10% friction loss of that force, but pretty close when you think about it in just in terms of the parts. How many different pieces of rope are coming from that moving block gives you your purchase. Dead eyes, hearts, and collars. So here I'm just going to point out, get back there, dead eyes, hearts, and throats. So again, we have dead eyes here. They're going to have these kind of eyes or grooves that are drilled into the wood there. A heart is going to be an open-faced. It has the same purpose. It's for a lanyard, but it's going to have grooves instead of the eyes, and it's going to be more open-faced. So these are called hearts. And then in terms of the collars, it's actually difficult to see. I think this, but here there's a collar. We don't have a lot of collars on board except for on the forestays, I believe. Maybe a couple other places. But it actually allows there to be a little bit of a wider lead for connecting to the bowsprit. Clear that again. Close that. So standing rigging setup. So here's a picture of some of our crew. I believe they're tying seizings, and behind them, above them, is some of the gun tackles or rig tackles set up. So on the right here, so we have our standing rig, whatever that is, whether we call it a backstay here. That's going. This is an example. This is perfect here because it's this is an iron strap here around this. But here we have the dead eye, so the upper dead eye and the lower dead eye. Then in between we have the lanyard, which is then going to get connected to this hook here, onto this tackle here, and then we have our rig tackle. And so we're actually increasing the purchase that we're able, because we have the parts here for this movable block. Then we also have these parts that we're pulling up. And finally, this line here goes down to deck and allows us to pull tension with our crew. Oh, I'll clear that. So here we have the topmast and the lower mast. This is actually a few years ago. We periodically take the lower mast out so that we can check them, do maintenance, and have a chance to do maintenance on the lower rigging as well. So we have the lower mast here, the lower mast cap. We have the fighting top, freshly painted and brand new. Then right here is actually the topmast. So in this situation, we actually set up the topmast and its rigging with the lower mast, so that later on when we put in the lower mast with the crane, it's all ready to go, and all we have to do is push it up rather than having to put on the cross trees and the cap for the lower mast and all of its associated rigging. So some other parts here, we'll be talking about sending up a mast a little bit later here in the session. And I wanted to kind of point out here in the upper right-hand corner photo, this is what we call like the Ansel block is something we call it. We'll call it for tonight's purpose, a mast rope block. And this is the mast rope. And this is actually what we're going to use to push up or send up the topmast once the lower mast is in place. So I'll point that out, but we'll see that again in a few more slides. Here in the lower right-hand corner, you can see some of the topmast associated cross trees, topmast cap right there. Then we have the topmast shrouds and topmast backstays, so you can kind of see what they look like. On the lower left-hand corner here, this is it kind of looks like it's upright, but it's actually still on its side. But we have the lower mast here, the topmast on the left there. This is the fighting top. Then we have the bolster underneath these eyes here. And then these are going to be our, actually going to be the shrouds of the lower mast. And you can see how they're then clamped together. These are two parts of the same rigging here. But they're seized together with a round seizing, so that makes them two shrouds. And then there's one that is a single. That's the Swifter shroud, which is a single part, and that's going to be spliced, and that's why it's so much thicker around right here, because that's actually spliced in. Around the lower mast here at the hounds, where the rigging is, these are going to be battens, and that's where the rigging is going to settle onto. Here we have some more shots of the rigging in action, if you will, even if it's not moving. So yeah, we have the hounds right here, where the rigging is settling and not able to slide down. Over on the right here, we have topmast shrouds. Again, you can see the round seizings. The lower right-hand corner, this is the main topmast stay. Again, it's the same standing rig. It's just seized together here with a round turn. You'll see some lines here attached. Those are the running rigging for the braces, or possibly a halyard dead end. Quite a view there. Here's a degallant mast in the center being sent up. We're actually going to talk more about that in a second, once we get to it. Here we have examples of more standing rigging. Just kind of a review a little bit here. Some of the items we have. We have the ratlins on the shrouds here. So we have our lower shrouds. Here on the Swifter shroud, you can see there's actually an example of service, which is wrapped around again to protect it. For us, because we have synthetic Kevlar standing rigging, this service here is actually to protect more from chafe rather than from the weather. This material here holds up pretty well under the UV. We do have it painted black for visual purposes to make it look more traditional. We have our futtock shrouds. Again, you can see it's tied into the lower shroud here, connected with hooks there under the fighting top, which then connects to the dead eyes of the shrouds for the topmast shrouds. So we have our topmast shrouds that go to the dead eye, they then go to the lanyard, they then go to the dead eye, which goes to the iron, which then goes to the futtock shroud, which then goes to the lower shroud. So it's all connected. Here we have that picture of the ship's bosun. She's here. This is the mainstay. She has tied a throat seizing here around the heart, and now she's putting in a round seizing. And again, she's using a rigging vise. I think the reason we're doing this is we had a crack in the other heart, so she had to cut all the other former old seizings here, open up the stay, get a new heart, put it in, do a throat seizing, and then she's doing the two round seizings associated with it. And then here there's also service here around that as well. Then the right here, we have a little bit of a shot with crew in the head rig. So we have our 4 stays here. This is the collars that I was talking about, the horse collars, that allow us to then have those go around the bowsprit. And we're using what's called come-alongs. You could use tackle, but come-alongs are going to be a little bit more efficient for tensioning those stays. Up here we have the foretopmast stays, so that's going to be the inner and the outer foretopmast stays. Here we have our jib boom. Here have one of our crew members in what's called a bosun's chair, or we have 2 crew members doing that. Down here we have our bob stays. So lots of things being worked on here in the head rig in the early part of this uprig season, which this would have been 2019. So next, we're going to kind of get towards the end here. We're going to be sending up a mast. So first I wanted to point out the tool that we use that, and I believe I briefly talked about it in our first session, but here we have our glorious, simple Mechanical Advantage machine here, like a giant winch. This is our capstan. And then we have all of our individual capstan bars, which you can see we have individual crew members leaning over those bars. And there's 10 of them, and they walk around. And then we have a line here that's going to be around the capstan. And then the end is tailed by a crew member, usually one of our able-bodied seafarers, and he's tailing that line there. This in particular is going to be a mast rope. So we're sending up one of the, or pushing up one of the masts. So we can see there's the capstan. We have the line wrapped around, the person tailing. It goes here. There's a turning block, which then directs the mast rope up aloft. And we'll talk more about that, what it looks like. But there's the capstan. That's going to be what we use to set up all the masts and lower yards. Here's a couple of photos of a topgallant mast, in particular the fore topgallant being sent up. So fore topgallant here. Some parts I'll point out. So we have the heel of it, which is going to be the lower part. Right here, which I'll talk more about this, there's a fid hole. So finally, when the mast is in position, it's been pushed all the way up and it's ready to be where it's going to be for the season. We push an iron fid through it, and that's what the mast rests on onto the trestle trees. So right here, that we have a line going through it right now. That's going to be the holdback line. This right here, this is actually the mast rope that we were talking about, coming up from the capstan. So the capstan is actually going to be walking around on this same line. And I'll go through that process. But you can see this rope here, this mast rope goes down through what's called a dumb shiv. So it doesn't move, but it's a smoothed out hole in the lower part of the mast. And then that mast rope goes back up. And then we have this, the fair leads there for the mast rope. We call them bunny ears, but they allow the mast rope to stay close to the upper part of the mast rather than the lower or the upper part of the mast just falling down. So it allows that force to be applied for the head of the mast, but really go through the lower part. And that allows the mast, now we're looking at the left side, that allows the mast to then go, the mast rope to go through the bottom of the mast, but to actually push the top of it up through first. Here we have another angle. And this is a topgallant mast, but this one is going to be on the main. So here we have our heel, our holdback line, again the dumb shiv. We have our mast rope, our fair leads there. The middle here, good example. There's actually some grooves in to the mast. I think on the right you can see it a little bit. That's just to help guide the mast rope a little bit. And then it goes up through the hole here in between the trestle trees. And then finally the head of the mast is going to go through the hole in the cap. Here's some other close-ups up aloft. So on the right here, we have a close-up. This is actually going to be the topgallant mast. We have the fid hole. You can see that groove for the mast rope. And right now this T-gallant mast is kind of housed in place while they dress the mast. So after you push up the mast or send up the mast, you actually have to put all the rigging on it after. So that rigging, that standing rigging, has to be sent up and then laid over the top until it rests on the hounds. On the left-hand side, we have the, this is actually going to be the topmast. So we have the fighting top here. This is the topmast. And then this is going to be the trussel trees. And then we have the fid. So the iron fid there that goes through the fid hole and lands or lays on the trussel tree, which then the topmast here rests right onto that. So the force of the topmast is transferred onto the trussel trees on either side of the lower mast trussel trees. Here's some other close-up shots. Different views. So here we have our topmast. Or actually, this is more likely a, looks like it's going to be a T-gallant mast. But we have our fid here on the trussel trees. And then I wanted to point out we have some wedges. So we do put wedges in. Once the mast has been fitted, the wedges there to keep the heel of the mast from sliding around. So it really locks in the heel of the mast around in the cross trees and the trussel trees right there. In the middle here, middle photo here, this is what we have, that mast rope block. We use an Ansel block, and this is the mast rope going through. We'll be talking about this, but the very end of the mast rope is what we call dead-ended, which is it's just tied around the cap right there. And then that then goes down to the yard, comes back up, then it goes through this mast rope block, and then down to the capstan, which we'll talk more about in a second. So we're going to be talking about setting up a topmast. So again, we have the heel, which is the bottom part. We have the fid hole. Then we have the dumb shiv, which is that rounded hole that provides allows the mast rope to go through. Then there's a groove into the mast that helps direct the mast rope. We have the T-gallant or the topmast hounds. Then we have that fair lead. So there's shackles that the mast rope is going to go through, and they're held with this line here connecting the two shackles around the mast on either side. And then again, this is to be a fair lead for those mast ropes. Then finally, we have the head. That's where the cap is eventually going to go on once all the rigging is on, once the mast is up there. So this should be interesting, so bear with me. This is my attempt to hopefully make this a little bit more visual for everyone. So looking in the upper right-hand corner, kind of how it looks like at the lower cap. So the lower cap being right here, the top of the lower mast. So we are to have it dead-ended, the mast rope around the cap. Then it's going to go down. So it's here, it's dead-ended. It's going to go down to the topmast, through that fair lead shackle, then follow down, go through the dumb shiv, then up on the other side, again through the other fair lead shackle. Then it's going to go up through the mast rope block, and then it's going to go down the deck through a turning block, and then go to the capstan where the crew are on the capstan bars. So as the crew on the capstan bars walk around, they're bringing tension on this end, which is going to bring tension on this end, tension on this end. It's going to move this end, this end. So the whole thing is going to start bringing that mast up. So as they're walking around, this is actually where I'm going to try and exit out of here. I'm going to go reshare. Now I can have access. So this is the point where as they're walking around, the mast will start going up. And again, we'll have a holdback line the holdback line. Let me go ahead and insert it right now. But the holdback line is to keep the mast from going directly into the lower mast so that you can keep up an angle instead of having to go straight up and down. We're going to continue going, bringing it up. Obviously, these are getting shorter here. Oh. These are getting shorter here. And then the mast, eventually we're going to continue to ease that holdback line until finally, as we get pretty close to going up through the fighting top between the trussel trees there, the mast is going to be pretty much vertical. And this is the part where it's important that the part of the mast rope is going through the heel and not through the top, is now we have to actually bring the top through the cap. And to be able to do that, we then take off the fair lead blocks. And then that allows, then we're really talking about the mast rope is just going through the heel. Oh, changing it all. So now we're just talking about the whole mast rope's going just through the heel, no more fair lead. And then once we get a significant part of the mast up above the cap and ready for putting the rigging on, this is where we then stop. We'll put a what's called a paw on the capstan so that the people on the bars can stop. We'll put a stopper on the mast rope, and then we'll tie off that mast rope on the pin or to the capstan itself. And then we'll usually, and I can go ahead to, then we'll normally tie up the mast to the lower mast, keep it in place, and then that's when the other rigging is dressed onto the topmast. Once that's all done, then the topmast cross trees are put on. So the cross trees are put on, topmast cap are put on, the rigging is all there, and then we're ready to go ahead and push up the mast again, or push it up the rest of the way. So at this point, it's pushed up all the way, up to the point of when the heel or the fid hole just gets above the fighting top or the trussel trees. Then that fid is put in place. Here we have a pink fid, and then the people in the capstan then walk back, and then the heel or the fid settles onto the trussel trees. And then you have your mast in place, your rigging has been dressed onto the mast, and now it's time to set up that rigging. So we have all the shrouds and backstays coming down off of the topmast. So now we have to set that up in the dead eyes on deck, and then start reeving the block and tackle or come-alongs, and then start tensioning that rigging in a process for tuning the rig. So that's how we set up a mast. That's how we get it and settle it, the fid onto the mast there. So hopefully that made it a little clearer for those of you there. We had some questions in the Facebook group, and I thought this was a great opportunity and a great session to introduce kind of this a little bit more complicated process of setting up the mast. So, all right, we're going to carry on. So, kind of as we wrap up here and get towards the end, some resources that if you're interested in, diving further into rigging, different types of marlin spike seamanship. These are some good resources. So in terms of marlin spike seamanship and doing some fancy work or learning how to do whippings or splices, The Arts of a Sailor is a really good resource, kind of in addition to the seamanship manual that we have. The Rigger's Apprentice is kind of a really all-encompassing. So that's going to have not only those knots and splices, but a lot about standing rigging, as well as some quits about modern and traditional rigging. So that's kind of a little bit of a rigger's Bible there that has a lot of good stuff. The Young Sea Officer's Sheet Anchor, we actually have a link of that on our course page. So you can access that, but it's free online. I think the link is through the Google Books, but it's from the 19th century, and it's a good resource that kind of show different aspects of rigging and during that period. In the upper right-hand corner, this is more for shipper clips, but Underhill has written a lot of books about traditional seamanship or rigging, and so his massing and rigging is a good one. There's lots of books out there. If you go on the Google Books and type in seamanship and have free books, there's a lot of free seamanship books out there from the 19th century. So there's a lot of different resources, more than you could ever get through. So just finding what works for you is good. But in terms of pointing you to a good resource, I found that The Arts of a Sailor is a good place to start for a lot of these fundamental seamanship skills. Oh, I'm going to clear that out again. Then here is a quick photo. This is going to be kind of our self-quiz for this week. So I'll definitely send this out in the email once the video is uploaded to the course page, as well as this will be on the course page tomorrow. But this will be kind of a quiz for you to kind of look around and try to find and trace out the different standing rigging, in particular the stays that are part of Niagara standing rig there. So hopefully that'll be helpful. I would encourage you to do a build a brig. So you print out that sheet, draw it out for yourself, again, label, and that can be quite helpful. So as we kind of get into our Q&A portion of this, for next week, again, visit the online sail training page. We're going to be talking about sails and running rigging next week. And I do suggest that you do your own build a brig sketch, do the self-quiz, and read pages 16 through 27 in the Seamanship Handbook there. So again, we're going to go into Q&A now. So if for those anybody have any questions, we can talk more about that. And then, yeah, we'll have that information to you with the email and everything next week. So I'm going to go ahead and turn on my video. Hello, everyone. And I'm going to invite Joe to do the same and welcome in here as we try to answer any questions you might have. Thanks, Ed, there. You said that you have a short video of Rhino. I think we might leave that for another time, but I'll talk to you about it. If anybody has any questions, we are here to answer them. So a question from Michael: are the upper masts ever lowered on Niagara for making on a bridge? Not the upper mast, yes. So the Royal and the Royal Topgallant mast is often lowered to get under bridges. In 2019, which was a busy year for us, where we went to all 5 Great Lakes, we had to go through the Welland Canal. We had to go into a place called Bayfield, Green Bay, Sault Ste. Marie. We actually had to lower and raise the masts about a dozen times. So in some seasons, in particular when the lake level is up really high, like it is right now in the Great Lakes, we will have to do that quite often. So it actually means that the crew have to do a lot more rigging in the summer, which makes them a lot more proficient at it. So by the end of those, the 2019 season, they were really good with housing the Topgallant mast on the main, pushing it back up, tuning it, and then re-seizing it quickly, which we had to do. So, yep, something we have to do quite often.
Are the hounds the same as a crow's nest? The hounds are basically the shoulders of the mast. So it's near the top, and it's where the various parts of the rig, rest on the upper part. Crow's nest is not something on our vessel, not really our era. A little before, it's a platform with walls around it at the top of the mast. So it's a tree house basically, on top of the cross trees of the fighting top.
Yeah, you see it a lot often in whaling ships during the previous decades or centuries, as you had mentioned. Question here from Christopher: will there be a course discussion on the advantages of the popular fashion of mast raking? We did talk about it in the last session a little bit in terms of why vessels have a rake in terms of advantages for rigging in particular and for backstays. As Joe mentioned, I believe the last session when he answered the question, really it was kind of a misnomer in terms of people believed vessels were faster when they had a extensive rake in terms of, like, think about the Baltimore Clippers, like the Pride of Baltimore 2. She has a lot more rake than, say, Niagara does. There are advantages to having some rake. And rake, to everybody who wasn't a part of that last session, rake is when a mast has a little bit of an after angle to it. So it's not straight up and down. It's actually leaning back a little bit. Most rake are going to be like ships like Niagara is going to be more like 4 to 7 degrees. Whereas with Pride of Baltimore, Joe, you remember the rake on Pride?
Oh, not in terms of angle.
Yeah.
Like I've said, I only remember the numbers that let me parallel park.
Yeah, maybe something like 11 or 12 degrees. Maybe that's a bit much, but it seems about right. But yeah, so there are advantages in terms of the backstays for rigging, especially with a square rigger, having that angle resist the force of the wind, and the force is going to be on it. It can have some advantages in terms of being able to brace lower yards around based on the different angles of shrouds, but it's not really a simple answer. And you'll notice that most modern vessels also don't have a significant amount of rake, or not extreme amount, and they're actually using running backstays and things to change the shell shape. So once you get into modern sail, you get a whole different can of worms there.
Are we ever going to see the details of the mast mounts in the hull? I can't get over everything being held together by friction. I'm guessing, Keith, you mean the mast step and the mast partners, where the bottom part of the mast attaches to the physical boat. Chris, do we have that in a future thing? Or should
I'll try to remember that and throw it in there, Keith. I do have some photos of when we were stepping the lower masts a few years ago, and definitely can throw. Hopefully, I have a shot or two of the actual step there, but I either have that or I have photos of our staff and crew doing it, putting it in place. So we'll see. But yeah, I'll try to remember to do that. Question from David: are there cases when the sails have to be drawn up quickly to keep the wind of a storm from blowing the brig over? It seems nothing is done quickly on the ship of this size. So David, I think you're getting at, do we have to take sail in quickly? Most of the time in our planning, we try to be pretty conservative in terms of reducing sail early. There are times when we have, like, say, lines of thunderstorms in the summer. We do have modern navigation and weather equipment so that we can generally see those lines of thunderstorms coming early, try to take things in before we have to. But there are times when, say, something develops right on top of you. And so, yeah, there are moments where we have to take things in quickly, and that's actually part of what we want to train with our crew and our trainees is doing things quickly so that you're trained up for when it needs to happen in those moments. So again, we try to prevent those times, but you can take in sail relatively quickly. Now, if you have the royals set, like if you're set to the royals, it's going to take some time, right? With those, you have to send crew off. It takes time to come down. But if we're going to have any kind of significant weather in the area, I would have hoped to have made a decision to take those in well before it's time to really get all the curtains in and the sails in. So it can be done quickly, but if you're caught with too much up, that's not going to be an advantageous situation.
Why does the rope wrap to the right instead of the left, and does it make a real difference? It's convention in this country, anyways, for most three-strand rope to be right-hand laid. I'd say it doesn't make a difference, except it's important that it's consistent for, operational issues. So does it matter if a screw tightens to the right and loosens to the left, or vice versa? Not really, but it's a lot easier if everything's consistent. So when you're, coiling rope or thinking about how it behaves under tension, right-hand laid rope will want to have a certain twist as it goes around corners, and left will want to behave differently. So short answer, doesn't matter, but it's really helpful to have it all the same.
Yep, definitely wouldn't want to switch back and forth all the time. Question here from Christopher. So Christopher actually sailed on the ship a couple of years ago and assisted in an uprig period as well. And he's talking about the topgallant mast and sending it up. And he was trying to remember about how many people were on that. I think for a topgallant mast going up, we generally don't need to man all 10 bars. We can certainly, but I think generally we'll have, if I remember correctly, about 6 people. Depending on how much force we're anticipating on it. It really is the topmast, the lower yards, the topsail yards are going to be the ones that are really heavy and going to need all 10 capstan bars on there. So we can't adjust how many people we have. Question here about the houses. So yeah, no, we don't do anything with the companionway houses or hatches. We don't need to actually do any moving of anything if we're doing a topmast versus a topgallant mast.
So Jay here notes that the Pride of Baltimore 2's website says the rake is 17 degrees.
All right.
Yeah, from my years working there, what I remember is we used to say 12, 12, 12, hit a bridge. How old is it? 12 years old. How many people live on board? There's 12 of us in the cabin. How many? How deep is it? 12 feet. Why are the masts like that? Hit a bridge.
Well, thanks, Jay, for taking a look at that. And yeah, I was definitely being conservative there, but 17 degrees is significant. Question here, kind of follow up with Christopher. Question is, do things have to be moved around to allow access to the full length of the capstan bars, assuming the weight of the topmast requires it? No, Christopher, we can usually get 2 people on a capstan bars. They are long enough to get around everything. So if we needed to throw more people on there, we could. Generally, the only time we do that more often than not is actually when we're hauling up the anchor and it's kind of caught and we need a little bit more oomph to get it out and broken out of the bottom. We can usually do a topmast or lower yards or anything with just the 10 people. It is sometimes if there's too much strain on that back rope, that might be where the capstan bars are having a harder time. And if you have the extra people, you could throw a couple extra people on the bars, but they can still usually get around or work it out where they're getting around.
The serving and the worming to make the lines easier to handle, smoother. So worm parceling serving is a process where you build up layers to make a line or rope more resistant to chafe and to moisture. So it's, if they had duct tape in 1812, they might have used that. But it's a process of building up layers that are not functional except to protect the rope. And so service and the rest of that is only used on rope, on line that doesn't have to bend under tension as part of its job. So standing rigging, stuff that stays in one place and supports the masts, things like that. Also like foot ropes, what have you, but it's not used on the running rigging, the stuff that moves back and forth to make parts of the sail move around. And it's overall smoother. It's also tends to be black and sticky from all the tar.
Yes, it is, especially after you freshly tarred it. All right, well, that's all the questions that we have up on the Q&A. Oh, there we go, a couple more. From Michael, so are baggy wrinkles to protect the sails and not the standing rigging? That is correct, Michael. So for anybody who doesn't know what a baggy wrinkle is, it is a kind of a weird shape mixture of rope that has been cut and wrapped around parts of where the standing rig is and where the sails will come up against the standing rig. And that really is protecting the sail from chafe with that stay or that place in the rigging. So yeah, baggy wrinkles, we don't have a lot on Niagara. But if you did have some hard spots or places you wanted to prevent chafe, you would use baggy wrinkles to do that. Usually baggy wrinkles are going to be made with some old rope that has been cut up. The strands have been cut up, and then they're cow hitched or lark-headed around another smaller piece of line, and then that line is wrapped around. If I can find a picture of a baggy wrinkle, I'll try to include it in the next session. It is a lot of people's favorite kind of terminology in rigging or in sailing. Baggy wrinkle is a kind of a unique one out there. All right. If there's no other questions, that's all we have for you this evening. No, one more from David. You want to take that there, Joe?
Is rope able to be made locally? Rope making could be a never-ending process. Rope making in any sort of decent quality and useful length is an industrial process. So, you know, you're typically in a ship using rope that's more than 100 feet long and has to have equal and even tension throughout the fibers through the length of it for it to be useful. So that's an industrial process happening in a sort of factory called a rope walk, and you'll still find some of those like on the East Coast. They're just very long, thin buildings where you're spiraling the fibers of the rope together. We can make things out of rope locally, but it's a manufactured good. It's generally one of the few things you can't make on board the ship, along with, I'd say, canvas. So it's something, if you're going around the world or something, you want to take a lot with you.
Yeah, a lot of rope and a lot of sail, and then you can do a lot of stuff with it. So. Question for Dave, or Thomas. On the picture for next week, there are horizontal lines between the shrouds and the mast. What are they for? Oh, that's a good question. Those are called crane lins, and they're used actually for the crew to lay out onto them to then go get to really the mast itself and the sail that's going to be there to be furled or stowed. The ones on the fore are going to be to furl the main topmast staysail. So those are crane lins that our crew clip into and climb out on and make their way over to the mast, and then that's where they work together to actually furl the sail. So that's what the crane lins are for. Oh, I bet, Bill, I bet you do have a lot of baggy wrinkles on Pioneer. A lot of the schooners, especially any that have wire rigging, will have a lot of baggy wrinkles.
Making rope, is there a way to determine the amount of twist to put in the strands of a certain diameter to make a rope that's not too loosely or tightly laid? I don't know. I'm more of a rope purchaser than a rope manufacturer, but I would say that because when you're looking at 3-strand rope, for example, the amount of twist is consistent across materials and brands. So there must be some underlying mechanical principle at work there.
Yeah, and then different manufacturers are gonna have their process for determining that. That's a whole other profession. I've never, outside of demonstration purposes, I've never actually made a rope that's going to be used on a vessel. So, question for Richard. So, how do they, or where do they get the rope when they're building the original ship? So, all the things that were a part of building and rigging the original Niagara here in Erie, because this was the wilderness, it wasn't yet a port city or port town. They wouldn't have the infrastructure to actually have that material already on hand. So it would all had to be brought here from the East Coast, essentially. Now, one of the major, largest kind of centers closer to Erie would have been Pittsburgh. So it's possible they would have had some, but at the very least, things would probably have gone through Pittsburgh or come from Buffalo or along the lake. But things had to come from the East Coast, where the main maritime port cities were in the early United States at that time, that would have been making the materials and then sent them to wherever they needed to be. All right, any other questions before we call it a night here? All right, well, again, thank you all for joining us. Joe, again, thank you for joining me and answering questions there. Yeah, it was a great session. Hopefully you got some value from it, and look out for that email. Again, the resources and the video will be on the course page by the end of the week. And next week, we'll be talking about sails and running rigging, which is going to be a lot of fun too. So have a great weekend, be safe, and we will see you next week.